Hi class. On this particular problem here, we want to find the standard deviation using this frequency distribution here. Unfortunately, StatCrunch is not going to help us with this problem. So the best thing to do is to open this in Excel. And here are the intervals and here are the frequencies. So what I need to do is I need to actually create a tabular type of approach here to calculate all these different elements and then compute the standard deviation. The first thing I have to do is find the midpoint. The midpoint is just going to be the sum of the lower and upper intervals divided by 2. So for 30 to 36, the answer is 33, 40, 47, 54, 61, 68, and so on. So this is just, again, just the sum of the limits divided by 2 to get these midpoints. Now I can compute x squared. That's just going to be the square of these numbers here, these midpoints right here. And then just take the frequency times x squared and put that in this column. And then the frequency times x and put that in this column. And then I'm going to sum all the numbers in the f x squared to get this result right here. And then sum all the numbers in the fx to get this result here. And notice here that we have an n here in the calculation. N is just going to be the sum of all the frequencies. So that's going to be 89. So take n times the sum of fx squared, and that's going to give us this number here. And then square this result, and that's going to give us this number here. Subtract these two numbers, and that gives us this number here. Divide it by n minus 1. As you see, I've done this formula right here. And then take the square root, and that gives us 9.3. And if I check 9.3 here, indeed, that is correct. Consider a difference of 20% between the two values of a standard deviation to be significant. How does this computed value compare to the given standard deviation of 11.1? So in essence, what they want me to do is take 11.1 and subtract from 9.3, and then divide that by 9.3, and that gives us 0.1935. Okay, so it looks like this is actually a little bit less than 20%. And actually, really, I think I did the calculation backwards, so it should be 11.1 minus 9.3 divided by 11.1, and that's 16.2. So again, same result here. It's still less. So the computed value is significantly is not significantly different because it's not in excess of 20%. And that's it. Thank you.